Welcome everyone to another learning session. In cloud computing, we are not doing anything completely different from what we were doing with on-premises. Instead, we are doing it on somebody else's data center. And what are those core things that we do on-premises and then do on cloud, which are also called as infrastructure as service components? It is nothing but virtual networks, virtual machines, and storage. Today, we are kickstarting our journey of learning about virtual networks. And most importantly, a very important part of virtual networks or all networks in general, including the World Wide Web or Internet, which is IP addresses. And later, from the perspective of virtual networks, we will see the concept of subnets also. And since we will be trying to solve some problems of IP addresses, I would advise you have some pen and paper also with you so that you can just write down and then share the answers in the chat later. So today, we will learn what IP addresses are, the differences between IPv4 and IPv6 addresses, introduction to CIDR, the concept of NID and HID bits, the concept of subnetworks and netmasks, the concept of private IP addresses, and finally, some problems to check your understanding. So what you need to know, basics of computers and computer networks are good to have. If you lack basics of computers and computer networks, I would suggest you watch the systems design videos from the YouTube channel. The shortcut to reach the YouTube channel is given below. It is http://yt.train.so. And also, it would be good to understand about binary, decimal, and hexadecimal numbers. And also the addition of binary numbers, plus understanding of the OSI model and TCP/IP is good to have. Again, something which we have discussed in the systems design videos in the TrainSo YouTube channel. Finally, an understanding of router, switch, or bridge is also good to have. All these things are good to have, but if you don't have this knowledge, don't worry. You will still be able to understand today's session. But our end goal is to become masters of cloud, right? For that, you also need to have these things, which you can definitely gain later by watching the videos from TrainSo YouTube channel. So quick note about me. Who do not know about me, I am an author, architect, and tech evangelist. And you can learn all about me from the link heartin.github.io, which I had created as part of the JIT 101 session. IP addresses. Every device in the internet have an address. We all live in different houses or apartments or PGs. All these real world places have some kind of address, right? If somebody wants to send a mail, then they will need an address to reach us. Similarly, every device that is connected to a network that follows the Internet Protocol address or IP protocol will need to have an address. And this address is a numerical address. And this address is called as an IP address. From a definition perspective, an IP address is a numerical label assigned to all devices connected to a computer network, such as the World Wide Web or Internet, or a local LAN network that uses Internet Protocol for communication. And An IP address helps in identifying the host and locating it on the network. Host is nothing but your machine. Today, IP address currently has two forms. One is IPv4 and one is IPv6. So IPv4 addresses are of 32 bits and IPv6 addresses are of 128 bits. Initially, there was only IPv4 and it consisted of just 32 bits. Because of that, we came to a situation where there won't be enough IP addresses for all our needs. So that is when everywhere people started to find ways to maximize the use. And one of those ways was to create a set of IP addresses that won't be used in public or that won't be used in public internet, called private IP addresses. So these private IP addresses can be used by companies within their corporate network or even individuals at their houses if they want. So in corporates, it really makes sense. And whenever somebody has to go out of the corporate network, they will definitely need a public IP address. So we'll see a public and private and all those things later. So when you compare IPv4 and IPv6 addresses, IPv4 address has a 32-bit length, which is divided into 4 parts. And each of these 4 parts have 8 bits each. Okay, how many of you do not understand bits and bytes? So ultimately, everything comes down to zeros and ones or bits, right? So it is a binary representation with using only zeros and ones. So when I say 32-bit, it could be 32 zeros and ones, a combination of it. This 32-bit based addressing was not enough for the growing need of internet. So IPv6 came into a picture. IPv6 has 128 bits and is divided into 8 parts of 16 bits each. And I don't think anytime soon that is going to exhaust. Okay, so each part of an IPv4 address is also called as octets and is represented in their decimal form in dot decimal format. So this 10.12.14.16 is called as a dot decimal format. And each part of the IPv6 address or hextets is represented in their hexadecimal form, separated by colons. This 2001, DB8, 0, 1, 2, 3, 4, all these things. Just understand that there are 2 kinds of IP addresses. And every website or device that you see on the internet will have an IP address. But then you might be asking, I am accessing a website from browser using some name, say trainso.com. So can somebody explain how the trainso.com gets converted to the actual IP address? Yes, it is a domain name system. Okay, domain name system or DNS converts between domain name and IP address and vice versa. We will not look into it right now. So one quick question to test your mathematical knowledge. What is the maximum decimal number that any of the 4 parts of an IPv4 address can contain? So an IPv4 address will look like 192.1.2.3. So instead of 3 or instead of 2 or instead of 1, what is the maximum decimal number I can have? An IPv4 address has 32 bits divided into 4 parts with 8 bits each. We already saw that. The largest binary number that can be represented by 8 bits is 1111. And its corresponding decimal value is 255. Okay, so the largest decimal number that any of the 4 parts of an IPv4 address can hold is 255. So now tell me, what is the largest hexadecimal number that any of the 8 parts of an IPv6 address can contain? It is FFFF. Okay. An IPv6 address has 128 bits divided into 8 parts with 16 bits each. The largest binary number that can be represented by 16 bits is 16 ones. And the corresponding hexadecimal value is FFFF. Therefore, the largest hexadecimal number that any of the 8 parts of an IPv6 address can hold is FFFF. Okay, there is a question. What is FFFF? It is a hexadecimal number. Okay, so similar to decimal numbers. So we generally see decimal numbers, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. These are decimal numbers. So similarly, you have binary numbers where it will be 0, 1, 1, 0, 1, 1, 1, 0, 0, and so on. Similarly, you have hexadecimal numbers. Okay, they also use some alphabets. It will be A to F in addition to the numbers. F is last, and then 4F is the largest one. So now let us get back to IP addresses. For simplicity, we'll be seeing examples with respect to IPv4 today, but the concepts are more or less same for IPv6 also. So every IP address that you use in your virtual network or networking in general has 2 parts, or we can consider 2 parts. The left side, or the most significant bits of an IP address, are called as network identifier bits, or network prefix, or routing prefix, and identifies a network or a subnetwork. And then rest of the bits, the least significant bits, the right side of an IP address, are called as host identifier bits or host identifier, and specifies a particular interface of a host on that network. In simple terms, the most significant bits will find the network or a virtual network or a subnet within that virtual network, and then rest of the bits will help you identify the actual host or machine within that virtual network or within that subnetwork. In today's networking, we use a format called as classless interdomain routing, or CIDR. It is called classless because previously we had something called as classful, and we will quickly look into classful in next slide. Classless interdomain routing, or CIDR notation, is a way of representing a range of IP addresses for IP addresses allocation and for IP routing purposes. CIDR introduced an administrative process of allocating address blocks to organizations based on their actual and short-term projected needs. So here you have flexibility for defining various IP address ranges. With the previous classful, you had less flexibility. We will see them. In CIDR notation, the routing prefix is specified as a suffix indicating the number of bits in the routing prefix. For example, an IPv4 representation of 192.0.2.0/24 means 24 bits are used as the routing prefix or network identifiers, and the rest, which is 8 bits. So total is 32, right? 32 minus 24 is 8. So rest 8 bits are available for host identification within the identified network. Similarly, in IPv6 representation, /32 means that 32 bits are used as a routing prefix, and the rest, which is 96 bits, the total is 128, right? 128 minus 32 is 96, is available for host identification within the identified network. And previously, we were using something called as a classful network addressing. It was used extensively to represent IPv4 addresses before CIDR. It was used on internet from 1981 until the introduction of classless interdomain routing or CIDR in 1993. In Classful, there were a lot of fixed sizes. For example, in Class A, NID had 8 bits, HID had 24 bits. Class B, NID had 16 bits, HID had again 16 bits. Total is again 32, right? Class C, NID had 24 bits and HID had 8 bits. And Class D and Class E does not have NID and HID separation. Class D is reserved for multicasting, and Class E is reserved for future uses. But with CIDR, address space allocation to internet service providers and end users is more flexible. So this allocation has to happen from an authority, right? So Azure will have a set of public IP addresses. AWS will have a set of public IP addresses. So they will be giving us those public IP addresses from within that pool that they have got. And as you know, public IP addresses are limited. So some cloud providers, what they do is, as long as that public IP address is being used on a resource such as virtual machine or something else, then they may not charge. But otherwise, if you are just reserving it without attaching it to a resource, then they will charge, because if you are attaching it to a resource, they will get money from that resource. But again, this can vary from cloud to cloud. So today's session, I am trying to keep it as much independent as possible from any cloud provider. All these things are common across any cloud provider or on-premises network even. So quick question: for an IPv4 address, if NID has 24 bits, HID has how many bits? For an IPv4 address, the total number of bits is 32. Therefore, if NID has 24 bits, then the HID will have 8 bits. Now, for an IPv6 address, if NID has 32 bits, HID has dash bits. The total number of bits is 128. Therefore, if NID has 24 bits, then the HID will have 96 bits. Calculating the number of IP addresses in a network. So whenever you are designing your virtual networks, or whenever you are designing your subnetworks, you may have to design for a particular number of IP addresses. Maybe you know I need n number of IP addresses. So you need to allocate that much IP addresses for that subnet. So how do we do that? So the number of IP addresses possible within a network can be calculated from the number of possible combinations of the HID bits. It's pure permutations and combinations from mathematics, right? And how do we do it? The formula is simple. It is 2 to the power of HID bits. For example, if number of HID bits is 4, then we can have how many? We can have 16 different IP addresses. That is calculated as 2 to the power of 4. And also, in general, we cannot use 2 IP addresses from our IP address range. The first one represent the network's ID, and the last one represent the directed broadcast IP address. So if we can have 16 IP addresses, then we may be able to use only 14 of them. And also, cloud providers may also have additional restrictions to this. So maybe a cloud provider will reserve 5 instead of these 2. Okay, quick note on unicasting versus broadcasting, since we saw that term. Unicasting means sending a message to a specific host IP address. And broadcasting means sending a message to multiple hosts. Broadcasting can be of 2 types. One is limited broadcasting, which refers to sending message to all hosts on the same network using the IP address 255.255.255.255. Directed broadcasting refers to sending messages to all hosts in another network using the directed broadcast IP address of the other network. The directed broadcast IP address of the other network is the last IP address within that network. or within a subnet. If the number of HID bits is 8, then how many different IP addresses are possible? I'll be testing your mathematical knowledge a lot in today's class. Okay, if the number of HID bits is 8, then we can have 256 different IP addresses calculated as 2 to the power 8. Then you might be asking why 255 earlier. So that was because we start from 0. The second question is, if the number of HID bits is 6, then how many IP addresses can we use? If the number of HID bits is 8, then in general, we can have 254 different IP addresses to use, calculated as 2 to the power of 8 minus 2. Again, there could be differences when it comes to different cloud providers. Subnetworks or subnets. A subnetwork or subnet is a logical division of an IP network. A network may be divided into subnetworks for easy maintenance and even security concerns. The practice of dividing a network into 2 or more networks is called as subnetting. So tell me, how can subnetworks or subnets help you with respect to easy maintenance or security concerns? Can you try to give some examples? Okay, one possible use case that we regularly use, I can share. In general, whenever you have a configuration such as this, you can have different subnets or subnetworks within your primary virtual network. And not all of your VMs or servers need to be accessed directly from the internet. Those VMs or servers which want internet access, which has to be accessed from the internet, can be put into one subnet, and we can define rules to say that, okay, allow internet access. And other servers or VMs, such as the database servers, we can put into another subnet, and we can configure permissions to tell that, okay, this subnet can be accessed only from other subnets within the same virtual network. So that means from the internet, you won't be able to access them directly. But what if some maintenance has to be done and somebody has to log into these database servers? So will they log in through a VM from subnet 1, or will they do something else? Have you heard that term or system through which you can jump to these private subnet servers? Okay, there is also a concept called as jump servers or bastion hosts through which you can access these servers. You'll be learning them in your respective cloud classes. But this is a practical use case that many people use. So always you have to try to secure your systems in all possible ways. And one of the ways is to make sure that you don't give any permission or access to anybody who doesn't need that permission or access, or least privilege policy. What happens to NID and HID bits with subnetting? The IP addresses for networks with subnets are logically divided into 2 parts: the network and subnet identifier, and also called as the routing prefix; the host identifier, the least significant bits, which is also called as the rest field. With the virtual networks, you may have n fields to identify the virtual network. You may add some more fields to identify the subnet. With subnetting, additional host identifier bits are used for subnet identification, and the routing prefix will now consist of both the network and subnet identifier bits. So the rest is only available for identifying machines. Computers that belong to a subnet are addressed with an identical routing prefix. Routing prefix means what? It's a combination of network identifier bits and subnet identifier bits. A simple diagram. So before subnetting, you have network identifier bits and host identifier bits. And with subnetting, you take some more bits from the host identifier part, and the whole network identifier plus subnet identifier part will be the routing prefix now. Again, a little bit of theory. Routers are special gateway computers that allow us to do selective routing of IP packets across multiple networks. Routers create borders between the subnets and manage traffic between them. Each subnet is served by a designated default router but may consist internally of multiple physical Ethernet segments interconnected by network switches. We don't have to dig deeper into a lot of networking concepts in today's session, but do explore more from the systems design discussions and also from future cloud-specific discussions. And there is this concept called as net mask or subnet mask, which is a bit mask in a dot decimal format that when applied by a bitwise AND operation to an IPv4 address, it yields the routing prefix bits. It's again mathematics. So net mask consists of leading ones corresponding to root bits and zeros corresponding to the host identifier bits. So you know a little bit of binary addition, right? What is 1 and 1? 1. What is 1 and 0? 0. Basically, with this addition, we can get the routing prefix. Okay, net mask is a value that is used by routers to calculate the routing prefix from an IP address. All the routing prefix side, you will have ones and rest you will have 0. Whatever is there in the routing prefix side will be returned as is. And whatever is there on the other side will be 0. So just play around with a little bit of binary addition. So consider the CIDR notation of 10.0.0.32/24. What will be the routing prefix or network identifier bits here? Network identifier bits or routing prefix is always the left side of an IP address. Right side will be host identifier bits. Okay, consider the CIDR notation of 10.0.0.32/24. The IP address can be represented in binary as follows. And the network mask for this would be all 24 in ones and rest 8 in zeros. And if we do an AND operation, what will happen? We will get 10.0.0.0. The last 32 will become 0 because they are the host identifier bits, which in the net mask is all zeros. Okay, so this is the routing identifier and is also the first IP within our CIDR block. Consider the CIDR notation of 10.0.0.32/24, where /24 is a subnet mask. If we use 2 more bits for subnet identification, then the subnet mask /24 for the subnet becomes dash. So currently the network mask is 24, and if we use 2 more for subnet identification, what will be the new subnet mask? So 24 plus 2 is 26, right? So now HID will have how many bits? 6. Okay, in CIDR notation 10.0.0.32/24, if we use 2 more bits for subnet identification, then the subnet mask for the subnet becomes /26, and HID will now have 6 bits. 32 minus 26. Very straightforward, right? So simple question, which is a bigger network of IP addresses, /24 or /26? All of you have answered it correctly. It is 24. /24 is a bigger network than /26. So bigger the size of the subnet mask will be smaller and vice versa. So this is because the subnet size is dependent on the HID bits, and HID bits are calculated by subtracting subnet mask from the total bits. For a subnet with a subnet mask of /24, there are 8 HID bits and hence 256 IP addresses. For a subnet with a subnet mask of /26, there are 6 HID bits and hence has 64 IP addresses. Okay, so then this concept of private IP addresses. Private IP addresses are not allocated to any specific organization. The other public IP addresses we saw, right? It is allocated, a range is allocated to maybe Amazon or Azure and all these companies. So these private IP addresses may be used without any approval. IP packets originating from or addressed to private IP addresses cannot be routed through the public internet. So from within your corporate network, if you search for what is the IP address in your machine, you might see one of these ranges. So RFC 1918 recommends the use of following ranges for private IP address. So 10.0.0.0 to 10.255.255.255 or 172.16.0.0 to 172.31.255.255 or 192.168.0.0 to 192.168.255.255. So which is the largest range out of these three? Okay, yeah, 10/8. So whenever you are doing ipconfig or checking within your machine, you might see one of these. But if you go to internet and check for what is my IP address, then you will see a public IP address. Okay, that translation happens before you actually go to the public internet. So more notes on private IPv6 addresses. Private IPv6 addresses consists of IPv6 addresses in the range FC00/7, referred to as unique local address or ULA, are unicast addresses but contain a 40-bit random number in the routing prefix to prevent collisions when two private networks are interconnected. May be used freely without centralized registration inside a single site or organization or spanning a limited number of sites or organizations. Are routable only within the scope of such private networks, but not in the global IPv6 internet. IPv6, the block FE80/10 is reserved for IP address link local auto configuration. So we will see IPv6 addresses in detail in a different session. Few more questions to check your understanding of IP addresses. Provide the range and number of IP addresses in this address space. 192.168.0.0/24. Range means what is the first IP address and what is the last IP address, and also number of IP addresses. So range means starting and ending has to be an IP address. So how many IP addresses are possible in this address space? Okay, usable is 254, actually is 256. Okay, let us, for calculations, let us consider the total IP addresses. Let us forget about usable and all. Okay, so it is 255. So the number of available IP addresses is 2 power 8, which is 256. So the range will be 0 to 255. Okay, so 192.168.0.0 to 192.168.0.255. Okay, so now comes the next stage, which you will be actually doing while designing your subnets. Consider this address space 192.168.0.0/24, divide it into two equal subnets. So two equal subnets means you'll have to give me two address spaces. So you already know how many IP addresses this address space can have from the previous question. So tell me, what will be the two IP address ranges? So you have to just give the CIDR notation similar to this. Okay, that is correct. So when you divide a network, so 24/24 becomes /25, /25 becomes /26. It is because the total number of bits is calculated by the power of 2, right? So you can do the math. Consider this address space 192.168.0.0/24. Divide it into 3 subnets following the below sizes. Consider this address space 192.168.0.0/24. Divide it into 3 subnets with following sizes: 64, 64, 128. So I need 3 address spaces. Okay, Pritham has shared 192.168.0.0/26, 192.168.0.64/26, 192.168.0.128/25, So the first part of a similar problem we have already solved, right? So here, first you have to divide the total 256 addresses into 128, and then you can split any of those 128 into 264. So here, Pritham has split the first one into 2. Okay, quick question. What if I wanted to split the second one instead of first one? Then what will be the IP address spaces? 192.168.0.0/25, 192.168.0.128/26, and third one 192.168.0.192/26. Basically, you'll have to add 64 more there. The answer for original question in the CIDR notation 192.168.0.0/24, it has 256 bits. So first you have to divide it into 2, and then you have to divide either one of those into 2 again. So as I mentioned, when you split /24 into 2, it will become /25. And when you split /25 into 2, it will become /26. Okay. Provide the range and number of IP addresses in this address space. 192.168.0.0/32. So what is 32 minus 32? It is 0, right? So what is 2 raised to 0? 2 to the power of 0? It is 1. Basically, /32 means there will be only 1. Assuming that you have all understood the things correctly, I want all of you to post your results in the group, or if you are watching it later on YouTube, you can post the results under it as a comment. So assignment question 1, provide the range and number of IP addresses in the address space 192.168.0.0/16. So assignment question 2, consider this address space 192.168.0.0/16, divide it into 2 equal subnets. Please do it on your own. Maybe you can watch it again, or maybe if you are watching it over YouTube, you can pause it, but try to do it on your own. Seeing somebody else's answers won't make you an expert. So try, and if you are making a mistake, it is perfectly fine. You can learn. You can ask why it is wrong, and then definitely I'll help you out. And final assignment question number 3, consider this address space 192.168.0.0/25, divide it into 3 subnets with the following sizes 32, 32, and 64. So even if you are not able to do it during the session, if you feel like it was fast for you to grasp and answer, you will definitely have to answer in your respective WhatsApp groups, and I'll personally be reviewing all of them. So the recording for this one will be uploaded to the Trainso YouTube channel. So this link http://yt.train.so will take you to that YouTube channel. So once the recording is ready, it will be uploaded there. So just dedicate your next 4 months into learning. 3 weeks and 3 weekends you can learn. 1 weekend per month, it will be free for you to do your other stuff. But other 3 weekends, please learn. And you can also use that extra weekend to cover up any missing topics. So that's it. Let us all learn together and grow together and become masters of cloud computing in 4 months.